Okay, so yesterday we talked about the writing the formulas. Today we're going to do writing the names from the formulas. And the reason we did it kind of backwards from the worksheet is because sometimes you have to look at what it's bonded with to figure out its charge, especially for our transition metals. So that's why we did it kind of backwards yesterday. So there are two naming systems that is recognized when we're naming compounds. The first one is the one that's listed here. It's called the IUPAC, and there's all the what it stands for. And the other one is called the stock naming system, which we don't really use in here. We use it in pre-AP, but not in here. But sometimes one will show up, and if it does, I'll just tell you what it is. We're going to use those Roman numerals for our transition metals, and I showed you that on the ion list where you have 2 or 3 behind it if it's an iron 2 or iron 3, etc. The old system would say ferric and ferrous chloride or whatever, so it's kind of confusing. But if you see one of those, don't panic, just come ask me, hey, what does this mean? Usually I try to catch it and tell you, but sometimes they slip through. So when we're writing these, unlike the molecular compounds, we will not be using prefixes. So on your worksheet, on the side that we're working on today, please at the top put don't use prefixes, because that's the biggest mistake that kids make when they're naming compounds, is they want to put prefixes on everything. Okay, you only use prefixes for molecular compounds which start with a nonmetal. So if it starts with a metal, like we'll see today, you're going to use just naming it. You're not going to use any prefixes. Okay. So the first thing is always the cation. We talked about that yesterday when we wrote the formulas. When we're writing the names, the cation always comes first, and it keeps its name. So if it's sodium, it's just sodium. If it's magnesium, it's just magnesium. No prefixes, it just gets its name. Okay. The thing about those transition metals, which these are the main ones we use right here, they will have to have that Roman numeral behind them. Okay. Every transition metal, except for 3 that we are going to memorize, can have more than one charge, and so that Roman numeral has to come behind it. Okay, the 3 exceptions are zinc, cadmium, and silver. And we don't see cadmium much, but we do see silver and zinc a lot. And if you look on your ion list, you'll see that they don't have a Roman numeral behind them. Okay, so you just have to memorize those. The anion is the last syllable. It's going to be the nonmetal. So chlorine becomes chloride, fluorine becomes fluoride, oxygen becomes oxide. That is just like what we did in the molecular. We're just not putting any prefixes with them. So they changed to IDE for the binary. Remember, binary is 2 things. Okay? So literally, we're just going to write what it says. So NaCl is sodium chloride. We just write what's there, because there's not. That is the only way that sodium and chlorine can bond. So that's why we don't need to use prefixes, because that's the only way they can go together. On this next one, we have CuS, and copper is one of those transition metals. So we have to decide if we have copper 1 or copper 2. And obviously you see this is copper 2, but the way that you figure that out is you look at what it's bonded with. In this case, it's bonded with sulfide. And what is the charge of a sulfide? It's group 16. We said everything in group 16 has a what charge? A -2. And so the fact that we know that the sulfide is a -2 and there's only 1 copper that goes with it, that means we have to have copper 2+. So then we would write it as copper 2 sulfide. And that's showing you the old naming system, cupric. Okay? But we're not going to, that's for pre-AP. We're not going to mess with the old school. Okay? So let's do some of these together. Okay? So the first one would literally be just what? Magnesium chloride. Sorry, that's my fault. I forgot to hit the little button. Magnesium chloride. Okay, and then the next one. Sodium phosphide. Okay, and then the next one, Ca3N2. Kinsey coal. What is it? Calcium. Remember when we do nitrogen, we change it to nitride. Yep. Okay, the next one is a transition metal. So we have iron. Okay, and if you look at your ion list, it's going to be either iron 2 or iron 3. So we're going to look at what it's bonded with to figure out what, excuse me, what it is. And so nitrogen is in group 15, and what do we say its charge would be? A -3. So if it's a -3, that means we have to have iron as a +3. So we would have iron 3 nitride. Okay? On the next one, lead, and we have chloride. Okay? What is the charge of a chloride? -1, but we have 2 of them, so it took 2 of them to go with 1 lead. So what does the charge of lead have to be? +2. So we have lead 2 chloride. Okay. Zinc is one of those exceptions to the transition metals. It only has 1 charge. Okay, so we don't have to put a Roman numeral. We're just going to call that zinc sulfide. And this is supposed to be a little b. It's supposed to be PbO2, sorry. All right. Yeah, it was when I added these in yesterday. I was changing it up, and I messed that one up. So oxygen normally is what charge? -2, but I have 2 of them. So it's taking 2 oxygen to go with 1 lead. So that means what should the charge of lead be? 4. So you would have lead 4 oxide. Now, if it is supposed to have a Roman numeral and you don't have the Roman numeral, it is going to be counted wrong. Okay? And the reason being is there is a difference between lead 2 oxide and lead 4 oxide. They are completely different chemicals that can react in completely different ways. Okay? So you have to be specific about telling whoever the reader is which one you have. Yes?
The transition metal only needs like 1, like it only needs 1 positive. Do we have to list the Roman numeral for 1?
Yes. Because copper, for instance, copper can be +1 or it can be +2. And you have to tell the reader which copper do you have. So even if it's just a +1, yes, you have to tell them. Okay. The only transition metals that don't need Roman numerals are zinc, cadmium, and silver. There's another 1 or 2, but we don't see them enough to worry about them. And then outside of the transition metals, lead and tin are not transition metals, but they do have the ability to have different charges. So that's why it's on the ion sheet as Roman numerals. So you have to know those as well. Okay? All right, so that's the binary when it's just a metal and a nonmetal. Let's talk about the ternary, which is the ones that include the polyatomic ions. Same thing, you still have to do the metal first, you still have to do Roman numerals, but now we need to look for the polyatomic ion. We do not change the names of polyatomic ions. If it is a nitrate, like right here, it stays a nitrate. Okay? So when you're doing these, best thing to do is look what becomes behind the metal and kind of like circle it and know that whatever comes behind the metal is going to be one of your polyatomics. And then you look that up on your pink sheet. So that would be nitrate. So that would just be potassium nitrate. This right here, if you look that up, is chromate. If you look up the charge of a chromate, you'll see that a chromate is a -2. So the fact that it took 2 copper to go with 1 chromate tells me that I have copper +1. So then I would name it as copper 1 chromate. Again, we're not worrying about that other naming system. Okay? So let's do some examples. There's not that many ternary examples in your notes, so we're going to do a few extra on here. Okay? So this first one was our journal question. So what was that called? Aluminum sulfate. Okay, here's our next one, copper, and then remember I said whatever comes behind the metal, circle it and know that it's going to be one of your polyatomics. Okay, what was confusing kids earlier in first period was they would do nitrogen and oxygen and they thought it was 2 separate things. That's one of our polyatomics. So we looked that up, and what is its charge? First of all, what is it? Nitrate, and what's its charge? It's a -1. Okay, so if it only took 1 of those to go with 1 copper, what charge of copper do we have? 1. Okay, so we would do copper 1 nitrate. Okay, So the next one, NH4Cl, is your one exception, because it is actually the only positive polyatomic ion, okay? So on any other time, I can tell you, look and see if it starts with a metal or a non-metal, and if it starts with a metal, it's going to be ionic. If it starts with a non-metal, it's going to be covalent molecular compound, okay? This is the one exception to that, because clearly nitrogen is a non-metal, but it's in that polyatomic ion. So you've got to recognize that NH4, and it's got a positive 1 charge, is our only polyatomic positive ion. And so that could throw you a little bit as far as naming it, okay? So that is ammonium. You can find it in the 5th ion list that we're doing. But so we would call this ammonium chloride. But make note of that in your notes, since that's not one of your examples, that is the one exception to if it starts with a metal, it's ionic. If it starts with a non-metal, okay? And then the last one, you have cesium, which is a metal, so we want to look up this ion. What is that ion? So we know this first part is cesium or cesium, however you want to say it. And what is ClO4? Perchlorate, which is one of our ions for tomorrow's quiz, right? On Friday. Okay? Are there any questions? Does it seem fairly straightforward? For your worksheet, what I would do if I were you is I would go through and find all your transition metals and like circle them so you know that you got to put Roman numerals on that. That way you don't just start naming them and forget to do it. Because if you don't have the Roman numerals, it is incorrect. So I encourage you to just go through and find your transition metals and circle them or put a star by them or something so you know you have to use Roman numerals. Okay? All right. That is the end of the lecture, and that's the end of the notes.